Hi there everyone and welcome back to final walkthrough series of Cambridge 7. Today we're going to discuss reading passage 3, effects of noise. Okay, so test number 4. First of all, pay attention to questions. We know that multiple choice questions, first of all, you can see that number 27, 28, and 29. They are multiple choice questions and we know the answers, they come in order. However, instead of just reading out the answers, it's better to just pay attention to the question, right? So we have the word because. Now the writer suggests that people may have difficulty sleeping in the mountains because, for some reason, in noise experiments, Glass and Singer found that. So the word, so they deduced, they made a conclusion. They found from some sort of an experiment. Researchers discovered that high noise levels are not likely to interfere. So the word, not likely. So and then we are followed by some sort of summary completion that requires for us to use letters with the suitable words here, and finally classifications, some text, basically some text. I'm gonna make this bold, basically some text, and we have to find their claimers, right? So in general, it is plausible to suppose that we should prefer peace and quiet to noise, and yet most of us have had the experience of having to adjust to sleeping in the mountains or countryside because it was initially too quiet, an experience that suggests that humans are capable of adapting to a wide range of noise levels. Research supports this view. For example, Glass and Singer, 1972, exposed people to short bursts of very loud noise and then measured their ability to work out problems and their psychological reactions to the noise. The noise was quite disruptive at first, but after about 4 minutes, the subjects were doing just as well on their tasks as control subjects who were not exposed to noise. Their psychological arousal also declined quickly to the same levels as those of control subjects. So I basically first of all found the word so to the first 27. So humans do not prefer peace and quiet noise. They may have. So basically, what is it saying here? That because what? Because they're saying yet most of us had the experience of having to adjust to sleeping on the mountains or the countryside because it was initially too quiet. An experiment that suggests that humans are capable of adapting to a wide range of noise levels. This means that most people have to adjust to sleeping in the mountains because they're not used to the quiet here. So which means they also have adapted to the noise in the city. So basically, so wide range of noise levels. So if they have adapted to that, so therefore humans do not prefer. No, they may have explored to short bursts. Humans prefer to hear a certain amount of noise while they sleep. They may have adapted to a higher noise level in the city. That's basically the answer for us. So I'm going to choose D for us. There we go. I'm going to eliminate, maybe not eliminate, but use the cyan color. All right, and noise experiments, Glass Singer. We also know that Glass and Singer, we know about the experiments. They did an experiment. So it says that okay, so the noise was quite disruptive at first. It was quite disruptive at first, but after about 4 minutes, the subjects were doing just as well on their tasks as control subjects who were not exposed to noise. Right, so this means that bursts of noise only affect the subjects at first, then they have no further effect. So, but problem solving is much easier under quiet conditions. No, I wouldn't say that is the answer. A is not correct because the result of the research shows that after about 4 minutes, it said 4 minutes, the subjects were doing just as well, and then on the so first of all. First, it was disruptive. Then, after 4 minutes, the subjects were doing just well. So, no, A is not the option. And B, psychological arousal prevents the ability to work. The psychological arousal also declined. So, basically, that one maybe, but I wouldn't say that. B is not correct because their psychological arousal also declined quickly to the same level as those of control subjects that we heard. We have this one. So psychological arousal also declined to the same level as those of the control subjects. B. Okay, so that is not the option. Bursts of noise do not seriously disrupt problem solving in the long term. Whoops, we have a mistake here. Okay, no, not really. So I would say that the psychological arousal of control subjects decline quickly. So I think this is the most suitable one, because D also doesn't really explain. Their psychological arousal also declined quickly to the same level as those of control subjects. I remember that. So it says, so basically because of that, the control group, they were not exposed to noise. So basically, no, D is not the answer. So I'm going to choose C first. So maybe take that. So once again, let's just quickly read that through. So burst of noise. So at first the noise was quite disruptive, but then after about 4 minutes, the subjects were doing just as well on their task as control subjects who were not exposed to noise. So they were not exposed to noise. So yeah, and the psychological arousal of control subjects. So they were not exposed to noise. So basically, D wouldn't be the answer. Now, we have to go more. So researchers discovered that high noise levels are not likely to interfere. All right, but there is a limit. There are limits to adaptation. Loud noise becomes more troublesome if the person is required to concentrate on more than one task. For example, high noise levels interfered with with the performances of subjects who are required to monitor 3 dials at a time. So we have 3 dials at a time. So basically, okay, 3 dials at a time. They had a difficulty, so I'm going to eliminate that. A task not unlike that of an airplane pilot or an air traffic controller. So there's another one. So B wouldn't be the answer as well. We're going to eliminate that. Similarly, noise did not affect a subject's ability to track a moving line with a steering wheel. But so we have this one as well. Did not. So successful performing, ability to repeat the numbers while tracking. Let's see that. But it did interfere with the subject's ability to repeat numbers while tracking. So yeah, option C is also going to get eliminated. So we're left with only with option A. So I'm going to choose that as an answer. But let me just remove this once again. So we're left with summary completion. Probably the most significant finding from research on noise is that its predictability is more important than how loud it is. So we are much more able to tune out chronic background noise, even if it is quite loud, than to work under circumstances with unexpected intrusions of noise. In the Glass and Singer study, so we have in the Glass and Singer study, take that. In which subjects were exposed to bursts of noise as they worked on a task. Some subjects heard loud bursts and others heard soft bursts. So I'm going to take that as well. For some subjects, the bursts were spaced exactly 1 minute apart. Others heard the same amount of noise overall. So they heard the same amount of noise overall, but the bursts occurred at random intervals. Random intervals means basically pauses, or some times where they pause the noise. So subjects reported finding the predictable and unpredictable noise equally annoying. They found it equally annoying, and all subjects performed at about the same level during the noise portion of the experiment. But the different noise conditions had quite different after effects when the subjects were required to proofread written material under conditions of no noise. As shown in table 1, the unpredictable noise produced more errors. So unpredictable errors in the later proofreading task. So we have then predictable noise, and soft unpredictable noise actually produced slightly more errors. So unpredictable noise produced more errors on this task than the loud, which is a predictable noise. Okay, so what do we have? Glass and Singer showed that situations in which there's intense noise have less effect on performance than circumstances in which we remember that here we are much more able to tune out chronic background noise, even if it is quite loud, than to work under circumstances with unexpected intrusions. This means that we are able to work better with intense noise if we obviously know. They're saying that if we know that noise is going to happen, we're going to work pretty fine. And so in which something noise occurs. So here we need some sort of an adjective. So we have the noise, and so a kind of noise. So what kind of a noise it is? Unexpected intrusions of noise. So unexpected noise should be there, right? There we go. We have B. We're going to eliminate that. Eliminate that. We have B, and we're going to put B here. All right. So I'm going to highlight them. All right. Subjects were divided into groups to perform a task. Some heard loud bursts of noise. Others saw it. For some subjects, the noise was predictable, while for others, its occurrence was random. We remember that it was here, random intervals. All groups were exposed to all groups were exposed to some sort of a noise. Another adjective here. So for some subjects, the bursts were spaced exactly 1 minute apart, predictable noise. Others heard the same amount of noise overall, but the bursts occurred at random intervals. Right? So same amount of noise overall, random intervals. So all groups were, and then it's saying others heard the same amount of noise overall. So same amount of noise, same amount. Oh, okay, we have it here. So we're going to remove it and put basically D there, and I'm going to basically highlight them. All right, the predictable noise group. All right, so there's an error here. The predictable noise group, the unpredictable noise group on this task. All right, we have some sort of comparison. And all subjects reported finding the predictable and unpredictable noise equally annoying. And all subjects performed at about the same levels during the noise portion of the experiment. It's equally annoying. Different types of made more mistakes than, showed more irritation than, no, performed at about the same level as. Did they? Finding the predictable and unpredictable noise equal and annoying, and all subjects performed at about the same level during the noise portion of the experiment. At about the same level? Same level, yeah, there we go. We have F as well. We're going to take that, and we're going to put number 32 as well, F. There we go. Okay, so in the second part of the experiment, the 4 groups were given a proofreading task to complete under conditions of no noise. They were required to check written materials for errors. The groups which had been exposed to unpredictable noise, the group. So I think I remember it was somewhere around here, that proofreading. Okay, but the different noise conditions. We need something here. But the different noise conditions had quite different after effects when the subjects were required to proofread. Okay, As shown in table 1, the unpredictable noise produced more errors. More errors in the later proofreading task than predictable noise. So they made more mistakes, did they? So they were required to check written materials for errors. The group which had been exposed to we have exposed to unpredictable noise. Unpredictable noise produced more errors in later proofreading tasks than predictable noise. With the predictable noise, they produced more errors, made more mistakes. There we go, we have it. So I there, I'm gonna put I and highlight it as well. So the group which had been exposed to loud predictable noise performed better than those who had heard soft unpredictable bursts. So we have soft unpredictable. The results suggest that apparently unpredictable noise produces unpredictable noise produces more fatigue than predictable noise, but it takes a while for this fatigue to take its toll on performance. To take an effect, produces fatigue, but that this manifests itself later. The sort of results should suggest that, but it takes a while for this fatigue. So it produces more fatigue. So it produces more fatigue here than predictable noise, but it takes a while for this fatigue to take its toll. That means it takes time for it to take an effect. So unpredictable noise. The results suggest that unpredictable noise. Do we have unpredictable? Where is it? Okay, we made a mistake here, I guess, right? But I pretty much. So I believe that okay, so 34 has to be B, I guess. 34 has to be here, B in here. But so 30, we made a mistake with number 30. But no, we didn't make a mistake, did we? Because we forgot for a second that you may use any letter more than once. There we go. Look at that. All right, so I was quite surprised for a second. All right, so next, now it's time for us to find these people. So this is a classification question. So Glassensinger, Broadbent, Finkel and Glass, Cohen et al. Or something similar. So, subjects exposed to noise find it difficult at first to concentrate on problem-solving tasks. So, okay. Predictability is not the only variable that reduces or eliminates the negative effects of noise. Another is control. If the individual knows that he or she can control the noise, this seems to eliminate both its negative effects at the time and its after effects. Do we have that? Don't I have? This is true if the individual never actually exercises his or her option to turn the noise off. I want to highlight this for myself. Okay, so just the knowledge that has control is sufficient. The studies discussed so far expose people to noise for only short periods, and only transient effects were studied. But the major worry about noisy environments is that living day after day with chronic noise may produce serious lasting effects. One study suggesting that this worry is a realistic one compared elementary school pupils who attended schools near Los Angeles' busiest airport with students who attended schools in quiet neighborhoods. Alright, we have it there. It was found that children from noisy schools and higher blood pressure had higher blood pressure and were more easily distracted than those who attended the quiet schools. Moreover, there was no evidence of adaptability to the noise. In fact, the longer the children had attended the noisy schools, the more predictable they became. The effects also seem to be long-lasting. A follow-up study showed that children who were moved to less noisy classrooms still showed greater distractibility 1 year later than students who had always been in these quiet schools. We have another Cohen et al, or whatever it is. And it should be noted that the two groups of children had been carefully matched by the investigators so that they were comparable in age, ethnicity, race, and social class. All right, so broadband. So we need to find broadband. We have broadband here, and we have Finkel and Glass here as well. All right, none of the above. So number 35, subjects exposed to noise find it difficult at first to concentrate on problem-solving tasks. In which subjects were it isn't necessarily here. I remember, there we go, we have Glass and Singer. For example, Glass and Singer exposed people to short bursts of very loud noise and then measured their ability to work out problems. To short bursts of very loud noise and then measure their ability to work out problems. Okay, and their psychological reactions to the noise. So who said it? Glass and Singer, obviously Glass and Singer. So we're gonna put A there. All right. Long-term exposure to noise can produce changes in behavior which can still be observed a year later. And then, okay, who said that? Long-term exposure to I remember long-lasting. We have long-lasting here. A follow-up study showed that children who were moved to less noisy classrooms still showed greater distractibility 1 year later than the students who had always been the quiet schools. Cohen et al. Said it? Did we have Cohen et al? We have it D. There we go. All right, so we have that as well. The problems associated with exposure to noise do not arise if the subject knows they can make it stop. All right, so the problems associated with the exposure to noise do not arise if the subject knows when they can make this stop. I remember here, if the individual knows that he or she can control the noise, this seems to eliminate both its negative effects at the time and its after effects. And the problems associated, who said that? Glass and Singer said it? Did Glass and Singer said that? Glass and Singer said it, right? Okay, we have Glass and Singer as well. So once again, A. Exposure to high-pitched noise results in more errors than exposure to low-pitched noise. Where was it mentioned? I remember it was mentioned somewhere right here. Or is it? No, high pitch. You know, high noise levels, high pitch noise. Okay, exposure to higher in more errors than exposure to low pitch noise. Here in paragraph 2, we know that broadband, he said, and high noise levels interfere with the performance of subjects who were required to monitor 3 dials at a time. A task not unlike that of an airplane pilot or an air traffic controller. Broadband, right? So he discovered that noise becomes a problem and we make more mistakes when a person has to concentrate on more than one task. So in terms of who made the research, do we have that? I'm just going to put E. Nobody made that research about it, because high exposure to high-pitched noise results in more errors than exposure to low-pitched noise. But broadband made high loads. He said it is saying that more errors, but here not really, because this is talking about how well we can adapt to a particular situation. And there were no errors in all situations. None of the researchers were doing any. They were not doing any experiments in terms of to find that. So we're not going to pretty much waste time. All right. So 39. Subjects find it difficult to perform 3 tasks at the same time when exposed to noise. We still have it. So subjects find it difficult to perform. Okay. Again, for example, high noise levels interfere with the performance of the subjects who were required to monitor 3 dials at a time. 3 dials at a time. So three dials at a time. A task not gonna like broadband. Who said it? Broadband said it. Yeah, broadband said it. Okay, we're gonna put B here. All right. Noise affects a subject's capacity to repeat numbers while carrying out another task. Noise affects a subject's capacity to repeat numbers while carrying out another task. Similarly, noise did not affect a subject's ability to track a moving line with a steering wheel, but it did interfere with the subject's ability to repeat numbers. Finkelman and Glass. Is that true? Yes. We have C here. There we go. So there we go, guys. Finally, we reached passage 3, test number 4. So I'm basically gonna be releasing my own platform where I'm going to be sharing the words that I have collected from each series, and I'm going to be also showing you whether or not you can use those words and the real exams, and how you can also utilize them in let's say writing task 2, for example, where writing task 2 pretty much requires critical thinking, and you obviously need to enrich your your mind with pretty fancy vocabulary that showcases in an accurate way. So whatever you want to say, you have to provide it in a much more accurate way, instead of using all the simple and very basic expressions. So yeah, so there you go, guys. If you find it helpful, please make sure to subscribe, like it if you obviously if you found it helpful. So thank you very much for watching. So in the future video, I'm still going to be still going to release a video about Cambridge 8. Thank you everyone, and have a wonderful time.